Today we will see another measure of central tendency, that is the mode. Mode means that the data value that occurs the most in the data set as compared to the rest of the values, right? So in ungrouped data, for ungrouped data there is no formula to calculate mode. You can just see the data, analyze it and get the mode. And one thing is that the mode can be unimodal, means there can be only one mode in data. The mode can be the data in the mode, you can say the mode can be bimodal, which means the data can have more than one mode, which means two modes. And the data can be multimodal, means there can be multiple modes, and even there can be any no mode in the data. Okay, so in the case of this, you can see ungrouped data, we will see how to see the mode. So you can see out of all these data values, 18 is the only value that occurs twice. No other value repeats two times or more than two times, right? It means that it doesn't mean that it is bimodal because 18 is existing two times. No, because it is the same value that is repeating two times, so it is called as the unimodal case. Okay, there is only one value that is repeating more than one, right? So see, in the next case you can see 19.2 is repeating two times, 1.1 is repeating two times, 2.7 is also repeating two times, right? Like these three values are repeating two times. It does not mean that since the values are repeating two times, so it is bimodal. No, because you can see that the mode, or you can say the occurrence of all the data values is same. There is no value that occurs more than the other ones, right? The occurrence of all data values is same. It means there exists no mode. You cannot say that the mode equals 0. It means that there is some data value which is 0, which is occurring the most, that is 0, so mode is 0. No, you have to write no mode, that there exists no mode in the data. And another case that you can see is this one. See here, 47 is repeating, no it's not, 52 is repeating two times, and 57 is also repeating two times, right? So there are two values, 52 and 57, that are repeating most, or you can say that they're repeating two times as compared to the rest of the values, and that rest of the values is 47 only. So as compared to this value, these two values are repeating twice. It means 57 and 52 are our modes, and they are bimodal. Why bimodal? Because we are getting two values as mode. Okay, so that was how to analyze the mode for the ungrouped data. But for the case of grouped data, we have a proper formula to calculate, like for the case of frequency distributions. Okay, so let's see that. Here is our formula. This L means the lower class boundary, this H is the class width. We have seen this many times, how to calculate class width and class boundaries. I will also tell you over here. So this FM, what is this? It means the frequency of the model class. The class where the mode occurs is called as the model class, and the frequency of that particular class is called as the, you can say, FM, and that is frequency of that class. Okay, and F1 means the frequency that is just above the model class frequency. Okay, and this F2 means the frequency that is just after the model class frequency. Okay, so that's the formula, you have to remember it. And one mistake that I have done is that here comes plus. Okay, you have to see this is plus, not multiplication. Okay, so next, after seeing all these terms, we will apply it through example. So here you can see the class where the frequency is the highest is called as the model class. If you can also say that the class where the mode occurs, right? And in case of group data, how the mode can occur in the form of frequency only, right? Because frequency tells that how many times that value is occurring. So the model class is the class where the frequency is the highest. Of course, you will be needing model class in order to apply this formula, because only of that model class we can use L and FM, etc., right? So firstly, for solving any problem, we have to know which is our model class by this thing, where the frequency is the highest. Okay, so here we have to find the mode for the given frequency distribution. We are given these boundaries already. We don't need to make the boundaries because we are given already. If we are not given the class boundaries but only class limits, then we have to find the class boundaries by subtracting, in this case 0.05 from the lower class boundary and adding 0.05 in the upper class boundary. We have discussed this already in the previous lectures. Okay, so now we know that firstly, in case of finding the mode for the grouped data, we have to know which class is our model class, right? So see, in all the frequencies, this 5 is the highest frequency. It means that this class is my model class, right? The class with the highest frequency is called as the model class, and the frequency of that model class is called as Fm, represented by Fm. And F1 is the you can say frequency that is just before the model class, and the frequency just after the model class is F2, right? And you will take the lower class boundary of the same model class, and because this h you can take from anywhere by subtracting this lower limit from this lower limit, because these all are of the same interval, same width, right? So whether you take 30.5 minus 25.5 or from here, it results in same, which is h is class width is 5. See the very first lecture if you don't know what is class width. Okay, so this is the formula. One thing is you have to you can say make it plus, otherwise the calculations are wrong, but I make sure that you know how to perform this or apply this formula step by step. Okay, here my L is what? L is the lower class boundary, that is you can see 20.5. my h is 5, so we have put 5 over here. Then my Fm is 5, right? And my F1 is what? It is 3. My F2 is 4. F1 is 3, right? So firstly, you don't have to just multiply this with this, but first you have to solve these parentheses. After solving the parenthesis, this one is plus. Okay, after solving the parenthesis, you have to multiply it with 5 and then add 20.5. So then you can see we will just a slight difference, that is 2 plus 1, that will be 3. 2 by 3 into 5. Okay, so you will get your mode, right? And one important note you have to see about mode is that mode is the only measure of the central tendency to find the most typical case when the data are nominal or categorical. Means when there is no math is involved, when there are only categorical or alphabetical qualitative data, then for finding the most typical case, or which you can say a value occurs the most, which case occurs the most, for that the only measure is mode. The median and the mean etc. are not applicable on the categorical data. Okay, this was an important point. So that's it for the mode. I hope you have understood it. So thank you.